Hello, this is MEI Further Maths Core Pure. We're in the Roots of Equations section and on the second video on using the relationship between roots and coefficients. You can watch the video straight through, but you will probably find it helpful sometimes to pause the video and try things out for yourself before continuing to watch. In the last video, we derived these relationships between the roots and coefficients of quadratic equations. We can use these properties to find the values of expressions involving the roots without having to find the actual roots themselves. Here's a straightforward example. The roots of 3x squared plus 2x minus 6 equals 0 are alpha and beta. But we're not asked to find alpha and beta, we're asked to find alpha plus beta and alpha beta. We can use the relationships we discovered last time. In our equation, A is 3, B is 2, and C is minus 6. We know that alpha plus beta is equal to minus B over A, and that's minus 2 over 3, minus 2/3. And we know that alpha beta is equal to C over A, and that's minus 6 over 3, which is minus 2. We had a similar set of relationships for cubic equations, and we can do the same thing. Here's another straightforward example, this time with a cubic equation. Here A is 2, B is minus 1, C is minus 2, and D is 1. Alpha plus beta plus gamma is minus B over A, and that's minus 1 over 2, minus a half. Alpha beta plus beta gamma plus gamma alpha is equal to C over A, and that's minus 2 over 2, which is minus 1. And alpha beta gamma is minus D over A, which is minus 1 over 2, minus a half. Those were straightforward examples, but we can also use a few tricks to find less obvious values. Here we're asked to find alpha squared plus beta squared plus gamma squared, and it looks as if we'd have to find alpha, beta and gamma and square them and add them. But consider this expression: alpha plus beta plus gamma all squared. That's alpha squared plus alpha beta plus alpha gamma plus beta alpha plus beta squared plus beta gamma plus gamma alpha plus gamma beta plus gamma squared. Collecting terms, we have alpha squared plus beta squared plus gamma squared. We've got alpha beta and beta alpha, so that's 2 lots of alpha beta. We've got beta gamma and gamma beta, so that's 2 lots of beta gamma. We've got alpha gamma and gamma alpha, so that's 2 lots of gamma alpha. I'm writing gamma alpha rather than alpha gamma because it gives a nice cyclic symmetry. But now we can see that the expression that we want, alpha squared plus beta squared plus gamma squared, is equal to alpha plus beta plus gamma all squared minus 2 lots of alpha beta plus beta gamma plus gamma alpha. And both the expressions on the right we can read straight from the equation. In my equation, A is 2, B is minus 1, C is minus 2, and D is 1. So alpha plus beta plus gamma, which is minus B over A, is a half, and we've got that squared. Then take away 2 lots of alpha beta plus beta gamma plus gamma alpha, and that's equal to C over A, which is minus 2 over 2. So that's a quarter plus 2, which is 9 over 4. So we were able to find alpha squared plus beta squared plus gamma squared without having to find alpha, beta and gamma first. There are more notes on integral on using the relationship between roots and coefficients. That's the end of this short video. The next video in the series is on forming equations with related roots.